Hello to the class Engineering Mechanics MG5002. So this week we learned a few topics such as the prerequisite knowledge. We have revised a couple of the mathematics relationships. For example, how to find the angle for right angle triangles, and how can we use different theories to determine the length or the angle for any of the triangle. Also, we learned how to calculate sine theta, cosine theta, tan theta for right angle triangles. So kind of a basic trigonometric relationships. You don't need to memorize these relationships. They will be provided in the formula sheet for the test and the exam. Also, we learned the sine rule for this type of triangles as shown in this image. So sine A divided by A, the length of that, equals sine B divided by the length which is opposite to the angle, equals sine C divided by the length opposite to the angle. Also, we learned cosine rule, which is if in case we want to determine the distance A, so we use the cosine rule. A square is equal B square plus C square minus 2BC cosine the angle opposite to the length A we're trying to determine, or the angle theta, or A, depends on what we're trying to find. Just basic things we need to know about areas of standard shapes. So if you want to find the area for rectangular, B times D, as you can see it in this figure. If we have a triangular, area is equal half of the base. The base is the length B times the height, which is h, from this distance to this distance. If it's a circle, area is equal pi over 4d square or pi r square. For these types of triangulars, area is equal half BC sine the angle D, or you can use the other relationships. Again, we don't need to memorize those formulas, so it will be provided for you in the formula sheet for the exam or the test. And here are different types of areas for different shapes, help you determine the values for them. We managed to solve a couple of the examples, determine the unknown sides and angles in the following figures. So for example, this one, you have this distance, or this length is 7 meters. This one is 9 meters. We want to find the unknown side and the angles. So we know this one is a 90 degree, but we're missing these two angles. So since it's a right angled triangle, we could use straightforward S squared is equal 7 squared plus 9 squared. We take the root square for that part of the equation, and then we find the value for S, which is 11.402 meters. Since the length of this triangle 7 and 9 are specified in meters units, therefore the length of S is also in meters. After that, we want to find the angle alpha and beta, because this one is 90 degrees. So tan alpha equals what? 7 divided by 9, and that will give you 37.875 degrees. And now either you subtract 180 minus 90 minus 37.875 will give you the 52.125, or use also tan beta is equal 9, which is the opposite to the angle, divided by 7. And beta will be equals to 52.125 degrees. And the same thing, you advise you guys to try it with other examples, such as you tried in the class. These are very important relationship to know, like angles are point added to 360 degrees. So we know like kind of a circle, 360 degrees. So if we know a couple of the angles, then we can determine the other one by subtracting the summation of these angles, three angles. We subtract them from the 360 degrees, and we find the angle is 45 degrees. Angles on the straight line to 180. So again, it's 180 the total angle minus 148 degrees will give you 32 degrees. It's very important to set up your calculators to radians, not radians, I mean to degrees, because some calculators are set up by default to radians. So just before you start working on this, just make sure your calculator is set to degrees. Another example, when two straight lines across each other opposite angles are equal. So A is equal to angle A is equal to angle C, angle D is equal to angle E. The same thing, alternate angles are equal when lines are parallel, so that 20 is equal to that 20. Corresponding angles are equal when lines are parallel, such as this example. And we did talk about in the class when you have 160 degrees here, if there's a parallel line to that line, then the angle will be the same. Co-interior angles added to 180 degrees. So technically, if you try to find when the lines are in parallel, so that if that's 20, this one 160 to give you the total, which is 180. So this angle and parallel lines rules, they're very important. You need to be familiar with them. They'll help you a lot. And then we did a couple of the examples, such as we did them in the class. I suggest you guys go through them and try to cover them. So you can start with this example, for example, find the length S. I'll give you time through the video so you can apply the equation, which you can see it is the cosine rule, which is a squared equals b squared plus c squared minus 2bc cosine a. And you substitute the values and then you find the distance S. Since the units are given for these lengths, therefore the final units for S is in meters. Also very important, we learned this week, the first week of this course, we're using SI units, System International units, and for example 10 to the power minus 6, it's micro. This is the simple for it. If it's 10 to the power minus 3, it's milli, M. If it's centi, 10 to the power minus 2, C, like centimeters. If it's DC, 10 to the power minus 1, D. We hardly use this one, but just you need to be familiar with it. And one is unity. Kilo is 10 to the power 3, okay, the simple. Mega is 10 to the power 6. And giga, again, this should be J, which is 10 to the power 9. So these samples are very known for us as a scale. Usually we work. So it's very nice if you get a big number like this, 11 or millions and 500 or something like that. So it's better to write it very nicely, 11.5 times 10 to the power 6 newtons or 11.5 mega newtons. Or on that way, we understand mega represent 10 to the power 6. I advise you to try this. Convert 100 millimeters to meters. Convert 1 kilonewtons to newtons. Convert 5 kilometers squared to meters squared. Remember, this is meters squared. Convert 100 millimeters cubic to meters cubic. Remember, this is millimeters cubic. And convert 36 kilometers per hour to meters per second. So standard units for us is newtons, meters squared, meters cubic for volume, and meters per second for velocity or speed. We don't submit the final answer in kilometers per hour if they haven't specified that. This is the answer for them. So always you can pause the video and you can check the answers. So this is technically kind of what we've done last week. So if we go back to the course descriptor, and we can see the first week, which is start 18th of February. We did some kind of basic prerequisites review, SI units, force, vector, addition, and we did cover introduction to forces on Friday. And next week we'll be doing equilibrium of concurrent forces, system in equilibrium, resultants, or equivalent vector. So whatever we land in forces. So what we did as well on Friday, so try to go through the topics on Friday. If you go to your Moodle class, you can click on Introduction to Forces. I strongly suggest you guys come to the topic here. Just make sure it's on my screen. Yeah. So we did kind of an overview. The first topic is Introduction to Forces. We learn how to describe the concept of statics and dynamic system. We'll discuss in more details very soon. State what is force and describe how it's represented by the arrows. Force, it's trying to give a motion to the body. We need to specify it with a magnitude and direction. And we learn how to calculate the resultant force, find the components of a force. So on Friday, you guys did the pre-class activities, and a couple of examples on YouTube videos will take you to some quizzes and you try them. Of course, if you want to read more about it, you need to click on that PDF file. And here is, again, we'll take you back to Introduction to Force, starting from the prerequisite knowledge from mathematics. But when you come to page, let's say page 6, you will start the introduction to forces and resultant force, such as the definition of force. A force is an interaction that, when unopposed, tends to change motion of an object. We always give an arrow at the end. We start with a straight line, we finish it with an arrow. We need to know the direction of the force. Of course, the units. Force is measured always in newtons. So always we focus on magnitude and direction. Direction means we need the angle. And if also we should learn about line of action. What's the action of the force? I did an example when I push a chair in the class. You can see the direction of the force is the direction where the end of the chair is going. So, but if I push in another direction, then definitely the chair will try to go in different ways. Units of force is in Newton. We learned how to read information, or how can we describe the force. So for example, if we have this force 30 newtons with 20 degrees and the east north, so we call it 30 newtons acting east 20 degrees north, or 30 newtons acting 20 degrees north of east. When you have a 45 degrees, we don't say west or north for this example, so 40 newtons acting northwest. Very important to know the direction of the arrow. So even this one looks like it's south, but the direction indicates it's going upward. So 15 newtons acting west, 60 degrees north, or 50 newtons acting 60 degrees north of west. So the arrow is very important. If the arrow was going downwards, that's where things would change and will be south. We also learned the relationship between mass and weight. We know that weight is equal mass times acceleration due to gravity, 9.81 meters per second square. The units to measure the weight is in newtons, similar to the force. Mass in kgs, that's the SI unit. So don't be tricked if we give you the mass in grams, so you need to convert that to kgs. Of course, the gravity acceleration in different planets will be different from the Earth, so that constant number is only for the Earth. And we did a couple of examples. I suggest you guys go through them again, and how to calculate the weights applying the equation mass times gravity acceleration. We learned what's the difference between resultants and equilibrants. They are the same, but there's just opposite direction for that. So the equilibrant of a force system is the single force that can be balanced the effects of the force system, which is balancing the resultant force. And then we learn how to calculate the resultants of two forces. We did this example in class, the work example, when you have two forces acting on a fixed pin, one pulled with 40 newtons on the this direction of the east, and another 160 degrees pull with 60 newtons, which is in the direction north of east. So the rules is very clearly, we start with the first direction of the force, the 40 newtons, from this point to where is the action to this point. At the end that point, we start parallel to that 60 newtons. We add another 60 newtons going, and the 60 degrees in the north of east. And then we close that by adding the resultance line, and you see the arrow of it. Using the cosine rule, straightforward, we can find the value of R, and using the sine rule, you can find the angle for the R resultant force acting, which is, we found it in the class and we did that. Also, there are another worked examples. I strongly recommend for you guys to try them before attempt the quizzes. And we covered the components of a force. Components of a force are the two forces which will have the same effects as the single force which they replace. So kind of, if you have a resultant force, you can take it back to components in X direction or Y direction, or horizontal and vertical direction, or with another parallel plane or on a perpendicular plane. Using the rules of the force times sine theta or cosine theta, because you need to analyze the force. And there's an example we did in the class on Friday, which is worked example 3.4. So I recommend you guys start this one. Resultant equilibrium force of system. Just try to go through it. There is a way you can calculate it by graphical methods, which I describe it for you guys. When I say if you have a ruler, you can really do it easily, and you don't need a calculator, and you can find the results very easy. And we learned we discussed if we could have a forces added to it. So if there is another force, as force is a vector, so where is the first force stopped? We continue in another arrow, and then we add, or could be going in the opposite direction as a negative. So always we use algebraic summation of forces in that one direction, and we could subtract on the other direction. We need to know the positive and negative. So summation of forces in horizontal represented by H, and summation of forces in V represented by vertical, and you can find the components for that. Very good example. Maybe we'll start the lecture on Monday by revising this topic with this example before we start the new topic. So another examples for you guys to try. Example 4.4, 4.5, and that's the end of that topic. So if you go back to Moodle class, topic 1, Introduction to Forces, definitely you can do the group activities, Introduction to Force worksheet. So we have a very nice set of questions for you guys to practice at home. You can practice as a group as well. And then post-class activities, self-evaluation, introduction to forces. So as a quiz you need to attempt, and there are heaps of questions, and we show the attempts for these quizzes. So when you take the quiz, you can see who is trying it, and I can see a couple of the students they have tried the quiz. So if you go back to the topic, and that's summarize the topic for Introduction to Force. So on Monday, if we check the date for that, will be the 25th of February. We start with a new topic, concurrent forces. It's a very interesting course. It will focus almost on the finding the components forces, and what's the difference between concurrent forces and non-concurrent forces, and how can we calculate algebraic summation of forces at one point in vertical direction or horizontal direction. So that's all for first week for you guys. I hope you enjoyed it, and hopefully you'll see me with another video regarding this topic. Thank you very much. See you in class. Bye-bye.